Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss about the mechanism of lubricants. So, how the mechanism is going to take place in the lubricants. So, here we are going to focus on three types, mainly thick film or fluid film or hydrodynamic lubrication, followed by thin film or boundary lubrication, and the last one is the extreme pressure lubrication. So we are going to discuss in detail about all the three lubrication types. So first, what is a lubricant? A lubricant is a substance which reduces the friction between the two moving surfaces. So it reduces the friction between the two moving surfaces. So these lubricants are used. So there are different types. It may be the mineral oil, it may be the solid form, semi-solid form, or the liquid form, or the gas. So there are different types of lubricants. So the petroleum byproducts are the mineral oils, are vegetable oils, are the paraffin wax, grease, graphene powder. These are the different types of lubricants. And even in the gaseous form, air is also the flow of air in between the two surfaces acts also as a lubricant. So how the mechanism is going to take place between the two surfaces. So there are three types of mechanisms involved in the mechanism of lubrication. So the usage of lubricants in a process is called the lubrication process. So the property exhibited by the lubricant is called the lubricity of the specific lubricant. So coming to the mechanism of lubrication, there are three types of lubrication. So the lubrication film between two contact surfaces it should be thick enough and two contact surfaces are separated completely by viscous or a film, viscous oil film. At this time, the frictional force of two contact surfaces or the moving surfaces are determined by viscous resistance of a lubricant, and it can be take a very small value, which means the coefficients of friction can be very less, like 0.0001. So there are three types of mechanisms involved in this lubrication, namely thick film, thin film, and extreme pressure. So thick film, thin film, and extreme pressure, they are the three types of mechanism involved in the lubrication process. So the thick film is also called as a fluid film or hydrodynamic lubrication, and the thin film or boundary lubrication is the thin film or also called as a boundary lubrication, and the final one is the extreme pressure lubrication. So these things we are going to see in detail how the mechanism is going to happen. So coming to the first and foremost mechanism type, which is called a thick film or the fluid film or hydrodynamic lubrication, it generally this occurs in a condition of under low load and high speed. So the load will be very less and the speed of the mechanism will be very high. So this carries out under the condition of low load and high speed mechanism. So under low load and high speed, a thick fluid of lubricant is maintained between the two moving or the solid surfaces. The thickness of the film is about at least 1000 Armstrongs. So the name itself indicates the thick film. So the lubricant level will be maintained at 1000 Armstrongs, which is very thick. It is maintained in between the two surfaces, two moving or two rigid surfaces. Since the thick fluid film separates the two solid surfaces, there is no contact, means there is no friction between the two surfaces because of the thick film present, the lubricant present as a thick film. So there is no possibility of coming in contact between the two surfaces. This reduces wear and tear, and there is no direct contact between the two surfaces. Suppose this is the surface, and this is the another surface. This is surface 1, surface 2. Here the thick layer. So this is the lubricant. So being a thick layer, this is thick layer of 1000 Armstrongs. So, being a thick layer, there is no possibility, there is no direct contact between these two surfaces. So, this coefficient friction is such, in such cases, is very low. Means the friction coefficient. So, the contact, if it comes in contact only, then the friction happens. So, the coefficient of the friction between these two surfaces is very, very low, and it is 0.01 to 0.03. So, it definitely, the usage of this thick film definitely increases the wear and tear of the machinery as well as the lifespan of the machinery, because there is no friction between the two surfaces and there is no heat production. So there is no possibility to damage, or there is no possibility to decrease the lifespan of the machinery. So it definitely increases or enhances the lifespan of the machinery and the wear and tear of the machinery. So here we can see this is the one surface, this is the surface, and this is the surface. So this is the thick film. Here 1, 2, 3, 3. These 5 dotted lines is the lubricant. So it is around 1000 degrees, 1000 Armstrongs. So due to the thick film between the two surfaces, this increases the lifespan of the machinery. So which is very thick. And the condition is it should be carried out and at low load and high speed. So the load should be very low and it can run at very high speed. So for example of this thick film lubrication is, consider the rotation of a shaft with respect to a stationary bearing. So here stationary means which is not moving. So here it is moving very fast. So the rotating shift in floating lubricant, thick film of lubricant. Here we can see this is the shaft, this is the shaft, this is the stationary bearing, and dotted line is the lubricant of thick film. So when it is rotating, here this shaft is rotating and this is stationary. Here what happens? This dotted line acts as a lubricant. It is in the this rotating shaft in floating lubricant. Thick film of lubricant definitely decreases the this friction between the two surfaces, because it is this surface, this is surface 1, surface 2. So this is separated by a thick film of lubricant. Here we can see here also lubricant. This is the rolling surface, and this is also moving. So it is moving this way and this is moving this way. So here it is separated by a lubricant which is called a thick film lubricant. So the definitely the coefficient which is called coefficient will be 0.0001 to 0.003. So the friction coefficient will be very less in these cases. So when a lubricant is added to the system, it occupies the annular surface. See the annular surface, here also annular surface, and the bearing, and forms a hydrodynamic. It remains and prevents contact between the two solid surfaces. See, we can see there is no contact in any of the area, because it is covered with annular surfaces, is covered with the lubricant here also. So there is no possibility on coming to direct contact between the two moving surfaces. When the load becomes very high, if suppose this we know it should be carried out at very low load, but if when the load becomes very high, the lubricant will be squeezed out of the wedge and the friction will occur. That's why this thick film has to be done at the low load and high speed. Here if the load is more, what happens here? If the load is more, it will come down and this will comes out with, it will squeeze us out because of the heavy load, because of the heavy weight. So this condition here, this thick film or the fluid film or the hydrodynamic film has to be carried out at very low loads. And this is the here under low load and high speed. Here we can see thick layer of lubricant. Here the hydrodynamic lubrication or the fluid film lubrication. Here this is the bearing center. If it is load is high, we can see here it will come out, because because of the heavy load, it will come, the lubricant will come out, and there is a possibility to come in contact with the another surface. So this has to be done at very low loads. So here in this case, means this type of lubrication mechanism is formed generally by mixing hydrocarbon oils and antioxidants with a long chain of polymers to maintain viscosity. Because to maintain the thickness, it has to be mixed with a mineral oil followed by the fatty acids or the antioxidants with a long chain of polymers. So the fluid film lubrication is useful in generally in delicate and light machines like watches, clocks, guns, scientific equipment, etc. So in triggers and all, we have to there will be a friction between the when we press the trigger, there will be a friction between the two surfaces. So in order to avoid, we have to use this lubricants. So the thick film, generally the fluid film or the thick film or hydrodynamic type of lubrication or the mechanism involves in this type of equipments like watches, guns, and scientific equipments. In the lab, this is in the laboratory. Coming to the next type, which is called thin film or boundary lubrication. Here, the condition is it occurs at under high load and slow speed, reverse. Whereas thick film or fluid film, it occurs in low load and high speed. Coming to this thin film, it should be done with a high load and very less speed. Under this condition of high load and slow speed, a continuous fluid film cannot be maintained because of high speed, because of high load between the moving surfaces. So under such condition, the thickness of the fluid film should be less than 1000. So where in that thick film we are maintaining 1000 angstroms, but here we have to maintain very less than the 1000. So such a thin consists of 2 or 3 molecules thick. So very less less thickness. To form a thin film, the lubricant has to be absorbed on the metal surface by physical or chemical force. So we have to maintain the thickness at very less quantity, means less than 100 angstroms. So in order to achieve that, we have to make a lubricant layer on the metal surface by the process of adsorption. It may be by the chemical force or by the physical force. So by means of physical or chemical, we have to make a thin layer on the surface of a metal. So here we can see this is the A and B. This is the solid surface. This is the film, fluid film. This is the adsorbed film. So a layer of film has to be done with the means of chemical or physical forces. So in some cases, the lubricants will react chemically with the metal surface. So the choice of lubricants is also important, because it should be coming to the properties of the lubricants. It should be chemically inert, and it should have the oxygen stability and the thermal stability. Sometimes the uses of these lubricants on the chemical on the absorption of like we are making a thin film by using chemical or physical means of force on the metal surfaces. So there is a possibility of reacting these lubricants with the metals. So the metals may undergo reduction or oxidation. So they both undergo a reaction. So forming a thin film of metal soap which acts as a lubricant. So here the thin film will be formed and which acts as a lubricant in between the two moving surfaces. This thin film is also known as a boundary film. The coefficient of friction in such cases is around 0.05 to 0.15. So here we can see this is lubricant film is formed here. The low speed and high load force surface together here. So if these are moving to, this is in this direction, here this direction. So this is the lubricant film is too thin to provide total surface separation. The contact between surfaces and between two surfaces are reduced by using the lubricants and provided by means of chemical additives. So coming to this, the effectiveness of this boundary lubricant depends on the oiliness of the lubricant. So the oiliness is the ability of a lubricant to stick onto the metal surface. Example, vegetable oil and the fatty acids have more oiliness. They stick easily onto the metal surfaces because of the high oiliness nature in their lubricants. An example oleic acid, which is C17H33COOH, and stearic acid, which is which is having carbon atoms of 17 molecules and hydrogen 35 and carboxylic group, which is called the stearic acid. So this stolic and stearic acid gives more oiliness. They stick easily onto the metal surface and forms a thin layer on the metal surfaces. So the polar group like carbonyl and this oil reacts with the metals. They contain carboxylic polar group. So the carbonyl group C double bond OH. So these polar groups have the capacity to react with the metal surface to form a continuous thin layer on the surface. So this lubricant has a capacity to react with the metal surfaces because of this carboxyl group, carbonyl group, and the hydrocarbon chain of the fatty acid gets oriented outwards in a perpendicular direction. So this is the uses of this more oiliness oil gives uh, gives the layer of thin film on the metal surfaces. Because of the carbonyl group, this lubricant reacts easily to the metal surfaces. So, what are the characteristics of thin film lubricants? So, it should have high viscosity index and resistance to heat and oxidation, the good oiliness and the low pour point, and the coefficient of friction results is 0.05 to 0.15 centimeter per second, and the thickness should be 20 to 30 angstroms. Whereas in thick film, it is around 1000 angstroms. Here, it was reducing around to 20 to 30 angstroms. Film formation by either physi-absorption or also by the chemi-absorption. So it may be by the chemical force or the physical force. The fatty acids and their soaps are used as the additives because to maintain this, these fatty acids and their soaps are used here with the combination of these lubricants. So what are the examples of thin film lubrication or boundary lubrication? Example, the main example means which have more oiliness nature. So that is vegetable and animal oils. So the vegetable oils consists of glycerides of higher fatty acid groups and their soaps. So these oils either physically absorbed to the metal surface or react chemically onto the material surfaces. Although these oil possess greater adhesion property, which adhere easily to the metal surfaces, yet they tend to break down at high temperature. Hence, fatty acids are added to improve the oiliness. So these oils like glycerides of higher fatty acids and their soaps, they have the adherence property. Adhesion property is more, but at higher temperature there is a possibility to break down. So for this, to avoid this, the fatty acids are added to improve this oiliness nature, so which sticks onto the surface very easily. And next example is graphite and molybdenum disulfide alone or oil suspension may be used because they have low internal friction. The internal friction will be very low. They can be wear or withstand compression. Even under the compression condition, they have the capability to wear and withstand. And the most thing is they are thermally stable. Even at high temperature, it won't break down. So graphite and molybdenum disulfide and oil suspensions are used because of these properties. Coming to the third type, which is called extreme pressure lubrication. And this condition is under high load and high speed. So if we see thick film means thick film, thin film, and extreme pressure. These are the three types. First one is low load, high speed. Thin film means high load, low speed. Here, high load, high speed. So this is the simple difference. If we see the thickness, it should be 1000 angstroms. If we see the thickness, it should be 20 to 30 angstroms. Here we will see how it is going to be there in the extreme pressure lubrication. So under this condition of high load and high pressure and high speed, more heat is generated between the moving surfaces. Because of high speed as well as the high load, there will be more high pressure. So the name itself is extreme pressure lubrication. As a result of this, the liquid lubricants which are using fails to stick and undergoes decomposition, or also it may break down or undergo decomposition, or also evaporation can happen because of the high speed and even with the high temperature. Under these conditions, for effective lubrication, in order to have a lubrication in an effective way, special additives known as extreme pressure additives are used or added along with the lubricants, because in order to avoid the evaporation or decomposition or breakdown of the specific lubricant, these extreme pressure lubricants are added. The extreme pressure additives are added to the lubricants. So the important extreme pressure additives are organic compounds having the active radicals. So the active radicals are groups means which are active, such as chlorine, example sulfurized oils, etc. So the active groups which are ready to react. So the active groups such as chlorines has to be added as an extreme pressure additive to the lubricants. So these compounds react with metallic surfaces. So we are applying on a metallic surfaces or a piece of metal. So here in a machinery there will be two surfaces made of metal. So we are adding on the metal surfaces to form a metallic chloride as the lubricant have. So this is the metal surface. So here, so we are adding the lubricant with extreme pressure additive. These are nothing but active groups such as chlorine. This is metal, we know. This is metal. So what happens? So this lubricant have chlorine groups. So these are readily react and form metallic chloride, which results in the metallic chlorides on its surface of a metal. So these metallic compounds possess high melting points and serve as a good lubricant even under extreme pressure conditions, because in this the high load and high speed means the rotation will be even more high speed and the load also will be very high. So these metallic chlorides, what happens, they have high melting points. So the melting character of these metallic chlorides will be high. So even at high temperature these are able to run as a good, they are able to act as a good lubricant, and it reduces the friction and increases the wear and tear and able to bear the high loads and high speed, because these metallic chlorides have high melting point. So even if this acts as a good lubricant under extreme pressure conditions. So what are the additives? So, organic compounds containing chlorine, sulfur and phosphorus. Chlorine, sulfur and phosphorus. These metallic compounds means chlorine or sulfur or phosphorus, they have high melting points. So they are able to withstand higher temperature. Esters, natural and synthetic fatty acids, as well as some solid materials such as graphite and molybdenum disulfide are used for these purposes. These molecules have a polar head and oil soluble tails. So the metal, which is the metal with chlorine or sulfur or phosphorus, it is called chemisorption, and then it is the modified metal surface, nothing but the metallic chlorines, metallic sulfurs or metallic phosphorus compounds which are having high melting point capability. So in reacting with these metal surfaces, these additive types form a new compound such as iron chlorides. So if the metal is iron, so it depends upon the metal which we took or metal which we choose. Metallic iron, this is metallic chloride. So here we took is iron. So here we are mentioning iron chlorides. Iron phosphides or iron sulfates depend upon the compound selection, or the depends upon the metal selection. So here we can see the polar head and oil soluble tail on the surface of the metal. So suppose if the metal is iron, it forms iron chlorides, iron sulfides and iron phosphates on the metal surfaces. So the metal salts produced a chemical soap-like film that acts as a barrier to reduce friction. So it is acting as a lubricant. Barrier means it is separating the two surfaces. Means It is acting as a lubricant and it reduces the friction. So the wear and metal scoring and eliminate the possibility of welding and also decrease the friction rate and decrease the production of heat between the two surfaces because it is acting as a barrier and acting as a lubricant in between the two surfaces. So this is about all the three thick film, thin film and extreme pressure lubrication. This is the mechanism involved in with very high speed, low speed and high speed at even at high loads. So the thick film is with low speed, low load and high speed. For thin film, the condition is high load and low speed. And for the extreme pressure conditions, extreme pressure lubrication, it occurs in high speed and high loads. This is the different types of mechanism involved with the lubricants. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.